I'm Charles. I'm the CEO of INTAMSYS. And as you know, that INTAMSYS is a company who is focused on the industrial FFF 3D printing solutions with innovative technology.
Hi, my name is Timm Woszidlo. I'm Technical Sales Manager in the EMEA region for INTAMSYS, and I'm very happy to have 3DPI today here at our booth.
Our company is from China, and we have a subsidiary in Europe and American market. Since the start of INTAMSYS 6 years ago, at that time there are very few companies who can provide the peak 3D printing solutions. So INTAMSYS is a pioneer. And two years later, we developed the second machine called the Pro 14. That machine is positioned to the more widely industrial application from the automotive, the aerospace, and also the general manufacturing. So in 2019, we see the market, the big size, the high performance material, low volume production. So we launched the 16HT.
The FUNMAT PRO 610 is our most advanced printer. It's a printer with a build volume from 610 to 508 to 508, and with a heated chamber up to 300 degrees, which is very unique in the market. So some people think with a 300-degree chamber, it's very specific, but I can tell you it isn't. Because we have customers that buy these machines to print PEEK or ULTEM, which seems to be obvious, but we have also customers that print it with just buy it for PC ABS, like the engineering plastics, because it's a very reliable solution.
This year, we bring our new machine called FUNMAT PRO 310. The keywords of this machine is that bring industrial performance to your desktop.
The Pro 310 is definitely made for everyone who really likes to print engineering plastics, because there are many desktop printers in the market, but there are not so many that can handle ABS, PC, ASA, PC ABS, PACF, all those more tougher plastics. Yeah? And with the 310, we can handle it. Why can we do it? Because we have a 100-degree C-heated chamber, yeah, and we have a very constant environment, and therefore we get also very constant and repeatable results. Besides the printer, you see the filament box, and this filament box is a bit special because it uses something called molecular sieve. Yeah, this molecular sieve here is something that maintains a low humidity, below 10% relative humidity, for more than 15 days. So this ensures, like, even if you print very tough materials like PACF, that they stay dry for more than 15 days.
So all this design and features is focused on to make the printer print zero engineering plastic and provide the industrial performance.
Yeah, I think the thermal design of our printers is really one of the main key benefits of our printers. And even at our very first desktop printer, the FUNMAT HT, we had a heated chamber, because we believe with a heated chamber you get better part strength, better surface appearance, less warping or no warping anymore, and more other benefits. I think it's always difficult to say which customers we have and what they are doing, because we have aerospace, automotive, machining, industry, and so on. But one part that we exhibit here from a customer is from a German company called Richter. And they are building lighting products. Yeah, they build lighting products for like a lounge in Dubai, like very high-end lighting products. And this is very nice because they have a requirement for flame retardant materials. They can't go with a usual 3D printer because having a flame retardant material is a requirement of the construction industry. So we have a part shown here from a customer, which is a bracket for a 6-axis robot. Yeah, this bracket is topology optimized, so it's more lightweight. Therefore, you have lower energy cost of the robot. You have less maintenance cost. Even if the part is pretty complex to produce, it brings multiple benefits in the end-used application. And this is what you see when you have stronger polymers. You can make stronger parts with getting better applications realized and therefore realizing more benefits out of it. I feel the trends are still the same than last year because people still look for more reliability, for more productivity of machines. So we see like people want to get parts faster printed, to make more parts in the same time, and they want to make serial production. So starting from a prototype, going to small series. Sustainability is definitely something where 3D printing can make a big impact, because especially the FFF technology is very materially efficient. Except the support material, you really need to only use the material you use for your part. If you machine a part, you have sometimes 80 or 90% just trash out of the part, which is hard to recycle always. What we see as a more general approach is we want to make our machines more reliable, we want to make the process more efficient, and in the end we want to reduce the production costs to make 3D printing more successful in serious production. So thank you everyone for listening to the video today. We are glad you were interested in INTAMSYS, and let us know when you have any thoughts about printing engineering plastics or high performance polymers.